in this second part, I'm going to show you how to solve the problem, the RMC problem, using the graphical method. And later on, I will actually show you how to do it using Solver. The graphical method is a pain to do. It is painful. It takes time. But once you do a few of them, it starts to get pretty easy. We're not going to use fancy graphing techniques in Excel. We're going to use what I call fake graphing. And as you know, there's a file that explains, tells you how to do it under course documents. So let's build a simple chart. Okay. Put it right there like that. It's already off. Okay. Copy, paste. Okay. I can guarantee a lot of mistakes because it's very difficult to do on the fly. Okay, so what you're going to do first is you're going to graph each of the lines represented by each of the constraints. Like your constraints are right here. Okay, no, I don't want to write anything now. I'll just do them one by one. So let's do the first one, which is this one, 0.4f plus 0.5s less or equal to 20. So how are you going to do that? Well, it's actually very simple. These are linear equations. They're just going to be lines, such as, okay, they're just going to look like this. It's just a matter of where they cross the axis and the slope. Okay, let me put it over here for later. So all you need to draw a line is 2 points. That's all you need. So if you take the first constraint, 0.4 plus 0.5s less or equal to 20, just make one of the variables, make it 0, and solve for the others. So let's start. Let's say that we make fuel 0. Okay, 0.4 times 0 plus 0.5 s less or equal to 20. Oh my God, what did I do there? God. All right. Okay, 0.4 times 0, that's 0. I'm doing it very slowly with a lot of steps so you can see, okay? Clearly, I don't do it that way. I do it for myself. Okay, so 0.5 s less or equal to 20. So if you divide, so 0.5 is multiplying. So if you divide both sides by 0.5, you will get 0.5 divided by 0.5 less or equal to 20 divided by 0.5. That will be 1s less or equal to 40. Okay, so what this means is when, I forgot to name this is going to be my solvent. This is going to be my fuel. So the fuel is going to be your x-axis, the solvent is going to be your y-axis. So when fuel is 0, that is all the way over here, solvent is 40. So let's just pick, let's say that this is 40. I don't know if I'm going to get in trouble. I'll pick something lower. Let's say that is 40. Okay, so that's 1 point. That's 0.040. Now, to the next one. I'm sorry, not the next one. Now, do the same for the other variable. So here you made f equal to 0. Now you're going to make s equal to 0. So you start the same place. Now you're going to make s, you're going to make it a 0. So just divide both sides by 0.4. So you're going to get, I'm skipping a couple steps here, 1f. (20) divided by 0.4. So 1 fuel is going to be equal to 50. 20 divided by 0.4, 50. Okay, so that's going to be, let's say here, this is 0.50, 0. Okay. So all you have to do now is connect these two dots, and there you go. That's your first constraint. Let me call it C1. Okay, that's your first constraint. What you're going to do is the same thing for the other two constraints in this case. So I just jumped ahead and I added the other lines for the other two constraints using the same method. Just take one at a time, make it 0, make one of the variables 0, solve for the other one, that creates 1 point, then switch, make the other variable 0, solve, get that point, and then just put a line through those 2 points. So now we have the 3 constraints. And now we're going to pay attention to the inequality, which we haven't yet. But let's do it. And actually, I'm going to do it on the side first to show you, and then we'll jump and do it in the problem. So this is just a little example. Okay? I'm going to build here. Okay. All right. And now let's say that we have a constraint, an imaginary constraint. And by the way, at this point, you should be thinking of guns and butter. Okay. If this is our constraint right here, and this is product A and product B, doesn't matter, does not matter. But this is your constraint, and the constraint tells you that it is less or equal to some amount, which is actually the case that we're looking at over here. This is also less or equal in all 3 cases. Not in the last case, but we'll see about that in a second. What it's telling you is everything down and to the left is feasible. Okay, everything to the left is feasible. In other words, your feasibility area is, actually, I forgot how I used to do this. Well, actually, there's one easy way of doing it, I guess. Nah, it's not gonna be a pain to build, is it? Nah, not so bad. Not so bad. There you go. That's your feasibility area right there. Everything to the left of the constraint. And if I change the let me change the transparency. Uh, um, no, I want a solid. Just gonna make it gray. Okay, better. That's that right there. That's the feasibility constraint um, for that constraint, for that line. Okay, everything to the left. If it was greater than equal, it would be everything to the right and up. Now back here again. So let's look at each of them one at a time and ignore. Okay, I'm gonna get these out of here. Bye bye. So you don't. It's still here. I'll show you one more time. Okay, but I'm just gonna move it over there. For the first constraint, which is zero point 0.4 times f plus 0.5 times s less or equal to 20, the feasibility area would be the area, and I'll throw some tiny little arrows. Okay, is that area. Okay, is that whole area over there. So I'm going to build a shade for that area. Not bad. Okay, that shaded area over there, that's for constraint number one. Now let's do number two. For number two is less or equal to 5. So it's going to be down to the left, but in this case, down will do it. So we are talking about, I lost my little arrows. Do I have them still? Yes, I do. So we're talking about the area down from constraint number two. So let's make that, let's shade the area. And I'm gonna pick a different color so we can see the, what happens later. So I'm gonna make it yellow. I'm gonna make it, come on. Okay. Put it. All right. And then finally, the last constraint, which is over there. So I'm going to take it. Come on. This is for constraint 3. I'll make that red. Or, yeah, something like that. Okay. Not bad, but it's not clear what I'm doing because of the transparencies. Let me see if I... Better. Better. What you're doing is you're trying to find the area that satisfies all three. And that area is the one with a different color. Now, of course, the blue one, the first one, is kind of hidden over here. But you can see that we have this area over here uh, built. It's a trapezoid of sorts. I'm going to highlight it. Do I have a trapezoid? Oh, I do, but can I? All right. No, no, that's not going to work. Let me do it by hand. Okay, insert. Okay. Is this area I'll make it green. Up to that point, and then down to that point, down to the x-axis, and then back to 0. That area is the only area that satisfies all three constraints. Notice this area, for example, only satisfies one constraint. This area over here only satisfies one constraint. This area right here, this triangle, actually satisfies two constraints, C3 and C1, because it's below both of them. Kind of the same thing happens with this little triangle over here. This also satisfies two constraints. That will be C2 and C1. Notice that tiny triangle, I'm going to zoom in. This tiny triangle here in the middle, that is actually not feasible because it only satisfies C2 and C3. It does not satisfy C1. C1 is a line that goes right through here, and it's telling us that all the values to the left are feasible, nothing to the right. So this triangle is actually not part of this feasibility area. So if we were to take this out of there, oh, I'm missing one chunk. There you go. Actually, I don't want to miss it again. So let's go back. Okay. And now I'm going to build a new chart just so you can see it a little more clear. All right, something like that. Okay, that is your feasibility area. Okay, all I did is I took it out of here, put in a new chart so you can see it. Now, at this point, we haven't said anything. We haven't mentioned the goal, the objective of this problem, which is to maximize the fuel and solvent profit. So what you need to do is now draw a not yet another line for that specific equation. To draw a line for the objective is a little bit of a guessing game. You just have to guess a value for the profit and then graph it. So, for example, and I'll use the same number that the book uses. Let's just say, just pick a value. You just need to pick one value out of thin air. Just pick one value. So the book says 240. I'm going to go with 240. Pick that value, and you can either, well, you can solve for 2 points like we did before, or you can find the slope of the line. Both ways are acceptable, but you can do it the same way we did it here. So you're going to draw that line, and that line is going to look something like this. If you were to do it, let me not mess up. Am I going to mess up this line? No. Actually, let me make it a little more dramatic. Okay. Let me change that. Okay. So this is the line for the objective. Okay. Now, any point on that line is not optimal. Is inside of the feasibility. You can do better than that. How much better? Well, look, you can do this much better, or that much better, that much better. Now, notice when you get to this point, this line now keeps going, right? Okay, you could make that much over here. Let me put a little star so you see what I'm talking about. Where are my stars? I'll use the lightning bolt. You could make that much right there. You could make it, but maybe it's not optimal. Now, what you cannot do is make the bolt is not working. Where's my star? You probably see the star right away. I can't. I'll use this one. You cannot use that point right there because that point is beyond the feasibility area. You cannot make that point. You can make this point because that point is within the feasibility. It's just maybe not is optimal. We don't know that yet. So the trick is how do you know when you reach an optimal? Because you keep moving this line. And how do you move that line? Oh, by the way, yeah, I haven't told you. The way you move that line is by trying multiple values for that profit. You just try 241, 242, 243, 244, and on and on and on and on and on and on until you hit a critical point like that. Let me zoom in. The optimal solution to this problem, you will find it where the objective line barely, well, not barely, but it touches a critical point on the feasibility line, and there are multiple critical points. There's one critical point here, one critical point here, one critical point here, and one critical point here, and one more. One critical point here. Those are the critical points. Your solution will always be at one of those critical points. But I can tell you this from experience, it's never going to be here, hardly ever going to be there at this point. It's one of these three. So which one is it? Well, all you have to do is equate your line to each of those 3 points. Actually, it cannot be this point. Now I just realized that it cannot be that point because it would be under. You can do better. And actually, it can't be that one either because right there is under. So it's going to be that point. Yep. Depending on how good you were with your graphing, mine is actually not bad. It's working quite well. You can determine that optimal point. In reality, you have to do the math. So how are we going to figure out where that point is? Well, that point is a point where two of your constraints are crossing over or hitting each other. Is this point right here is where C1 and C3 cross each other. So that's the point that we need to find out. And you do it by mathematically equating the two. Sorry, so this is C1 and this is C3. Yep. Ouch. Okay. Here. I'm gonna delete these. I don't need them anymore. Oh, come on. Just sorry that. And that one and that one. Okay, good. Okay, so that's the solution is going to be where these two equal each other. So let me show you how to do it. Let me show you the algebra for this. So pick one, doesn't matter. Let's pick the first one, first constraint, first variable. So it's going to be f right here. And write the formula in terms of that constraint. So 0.4f plus 0.5s greater or equal to 20 would be equal to 0.4f equal 20 minus the 0.5s, which is equal to f 20 divided by 4 by 0.4 minus 0.5s divided by 4, right, which equals f equals, that's 50 minus 1.25s. Okay, so now you have constraint 1 written in terms of f. Take that value of f, because that's what f equals to now, and put it in the second constraint. So I'm going to do it here, 0.6 parentheses. Now just write the equation that you just solved for, 50 minus 1.25s. From here, you just put it right there, plus 0.3 s less or equal to 21, which equals, God almighty, 30 minus 0.75 s plus, well, this is this part, plus 0.3 s equal 21. Yes. Oh, and by the way, I didn't say anything. I forgot to say it. So what I'm doing is, to solve for the 2, I'm dropping the equalities. I'm sorry, the inequalities, and I'm just putting equality. I'm just putting an equal sign, and that's okay, because all we're doing is we're making them equal to each other. So this less or equal to 20, I just made it an equal, and just kept going. Okay, so don't worry about that. So that's equal to negative 0.45 s minus equals minus 9. So s equals 20. Okay, so we got a first one. Solvent is going to be 20. Now, to solve for fuel, you got it up here. All you have to do is f equals 50 minus 1.25 20. I'm just taking the value 20, because I just solved that. I just figured that out. Put it in there, which I took from here. That is going to be equal to